Hello and welcome to Connect and Collaborate. I am Alex Hopkins, your on-air producer, and we are having our monthly check-in with the American Council of Engineering Companies of Colorado, better known as ACEC Colorado, and we're pretty excited for this show because this week is Engineers Week, and that happens every February, and so I have in studio to talk about Engineering Week with me and the future of the engineering profession. I have Bill Green. He is the president of RMH Group, and Lauren Evans, who is the president and founder of Pinyon Environmental. So how are you both doing today?
Good, Alex. Yeah. How are you?
Yeah. Fantastic. Thank you. Thanks for making it out on this cold, snowy day. And, you know, I feel like the traffic wasn't too terrible because it's President's Day and most people are off, you know. But we're here, so we're excited that you're here. One cool thing that we have in our studio, not a lot of people get to know this on air, is that we have some DeLoreans in the back, and you guys got a chance to see those. And I want to point out here that we have those. It's pretty exciting, and I feel like it fits with our past, present, and future show about the future of engineering profession. So we appreciate you guys coming in and seeing that.
Absolutely. Yeah.
Yeah. So I'm going to have you guys talk a little bit about your backgrounds and how you each got into the engineering profession. If you want to start, Lauren.
Sure. Well, I grew up outside in Philadelphia, and my degree is in geological engineering. And when I was 14, I took my first trip out here to the west and went to Yellowstone, the Grand Tetons, and the Grand Canyon. And how could you not get interested in geology from that trip? And so I had decided I wanted to study geology, and my dad is an engineer, and so he convinced me that getting an engineering degree with that would be a smart move. So I went to the School of Mines and got the geological engineering degree.
Yeah.
Awesome. Just a follow-up question. I did not know. So there's tons of different avenues you can take, first of all, within engineering. I did not know until right now that geological engineering existed. So apologies for not knowing about
okay.
that. What does that entail?
It's kind of a cross between geology and civil engineering. So a little bit heavier on the geology than a lot of civils get, but a lot of the civil engineering type courses. So there's not a lot of schools that provide that degree, but Mines is one of them.
Awesome. So. And have you felt like you've gotten a good use out of that degree? I mean, obviously you have your own company.
Absolutely.
Yes. Yeah. But as far as sticking with the geological aspect.
Yes, because a lot of what we deal with in environmental is contaminated soil and groundwater, and that's all part of geology. So
awesome. Thank you. How about you, Bill?
You know, I was born and raised in Grant Junction and went to school at CU Boulder. Started as a business major, and I had too much math to really take business math. So I ended up with a bunch of engineers in calculus. And I liked what they were doing more than what I was doing. So I switched majors, and it was really perfect for me. I'm kind of a mechanical kind of guy, car guy, so mechanical engineering is what I went into.
Awesome.
Yeah.
So I want to ask you, how far along into your degree, your business degree, were you when you decided to change?
Oh, probably about 6 months.
Oh, okay.
And so I had just started and hated business math, hated business courses, but loved programming computers, loved calculating stress and strain. So
that's awesome.
That. Yeah.
Good for you. Not a lot of people get you. I feel like you cut it off at the right time. 6 months in is not too much schooling wasted on the wrong degree.
That's right.
Let's talk about a baseline of where the engineering profession stands today. Bill, if you
Sure. You know, engineering is a very diverse profession. There's mechanical, electrical, civil, structural, environmental,
electrical,
sanitary, mining. I mean, all kinds of different degrees. So, and what people do within those is also very diverse. Mm-hmm. They can go into programming. They can go into robotics. There's such a wide variety of careers that they can pursue. So it's very exciting these days.
It is really exciting.
It really is. And if you look around you, and almost everything you look at, multiple engineers had something to do with it being here. You know, I used to do a thing for kids in elementary school. How many engineers does it take to make your alarm clock work? And and you think about like the plastic and the radio transmission and the electricity and transportation to get it there, and it's touched by many, many engineers.
That is, and it's fascinating to think about how many different avenues there are. As I said, I learn about a new career within engineering every time I have a show with ACEC Colorado, and it's pretty exciting to see that. My cell phone is now my alarm clock, and I'm sure that's touched by even more engineers nowadays, right? So it is a competitive market, though, right? I know that we need some schooling in there, and STEM education is very important. The E in STEM is engineering, as a matter of fact. But let's talk about that competitive market. You each have your own firms. Do you have trouble? Do you find that you always have an engineer at hand?
Do we have trouble finding engineers?
Yes.
I think it's a pretty tough time for those of us in business right now to find the staff we need.
Yeah.
So, because business is good, and so we've been pretty lucky. We've gotten some good local folks from CU and from mines, and so feel pretty lucky about that. But it is a very tight marketplace.
Yes, and by tight marketplace, meaning so you are well staffed. Are you turning applications away?
No, I mean it's hard to find people to hire.
Okay.
Yeah.
This is okay.
Right.
So we do have a shortage. Yeah.
Yes.
Yeah. Well, what are you looking for in an employee?
Well, first and foremost for us is, I think, problem solvers. I don't know, Bill, and people who can take a project and want to see it through to completion. In consulting, we work for clients, right? So they have a problem and an issue that they bring to us, and so we're looking for people who are passionate about solving those clients' problems for them.
Awesome. How about you, Bill?
Well, we too have a hard time finding people, especially people that, in consulting, you deal with clients. And so having, a good personality is critical. And so people that can get along with people are needed. But we also need folks that are very technical. And so finding a highly technical person that's also personable is somewhat hard to do.
I would imagine that there's some obstacles to get through there. I think we're starting to see the face of that change, particularly we talk about STEM. STEAM is now the new cool word, and that A stands for arts. And so typically those art creative people tend to be a little bit easier on the people-to-people model, right? So hopefully we can see some highly technical people get those softer customer service skills, if you will.
Right, and I think as we've been talking about before, that's going to be really critical as we go forward, because I think in the future we're going to have to do a much better job of explaining to the public why the projects that we're working on are important and needed. And I think engineers are going to have to be better communicators with the public.
Yeah, let's talk about that. Let's talk about the needs for a project and the benefits to the public.
Right.
Yeah.
So I think that's something we deal with in environmental all the time, because we're working on, things like fast tracks and what are the impacts to the environment, but which is a cost to society, right, in addition to the dollar cost, but then explaining the benefits that will come from it too, because as you see around the country, there's a lot of kind of not in my backyard going on about projects right now. And so we need to explain much better why they're needed.
Yeah. Well, do you mind? Can I ask you why? So, for example, what would be in my backyard that I would hate to get out, but why is it beneficial to me?
Let's see. You said you probably travel C70, right?
Yes.
So yes,
of course I do.
big project about to start on C70. Right?
Yeah.
A lot of good reasons to be doing that project. Congestion, so better air, less fuel use. less commute time, saving, that's a benefit to your life, right?
Yeah.
The viaduct has split a community. There's lots of reasons to be doing that project.
Yeah.
But
And the nice thing about that project, we've done a few interviews with CDOT ourselves, which has been really nice, but we got to see they're not just putting a road up, they're actually building an infrastructure over it and putting communities back in, which I think is really cool. It's not just tearing down, they're putting back, which I think is something that's relatively new that we're seeing.
Yes.
Yeah. Thoughts about benefits to the public for some projects that you guys work on?
Well, we do building systems, so a lot of our work deals with building energy efficiency. We design some renewable energy systems. We design some power generation systems also. So the change to the national grid is incredible. I mean, the amount of change that's happening right now with certainly wind energy, solar, that sort of thing. It's a great opportunity to reduce emissions, make it more cost effective, certainly better for the environment. So it has a huge impact, but I find most people have a little bit difficult time understanding what's real, what's hype, that sort of thing.
Yeah.
Yeah.
I agree with you. I think there's a level of transparency that maybe has been missing in the past. Is that something either one of your firms or yourselves have worked on, that we're getting to a place of transparency with the project? There's only so much you can share with the public, right, when you're going into a project. And I don't necessarily think I need to know the cost, but perhaps the hours that you plan on having infrastructure going up and how long things are going to take so that my everyday life isn't overly impacted.
Right. Yeah. On infrastructure projects like transportation, there's actually a lot of transparency that goes on, a lot of public meetings. It's a very long process. Takes years, from the conception to actually construction and completion. And there's a lot of required transparency throughout that process. But Bill and I both attended a session here in Colorado in October called Engineering Change Lab, which is looking at the future of the engineering profession. And one of the things that is an initiative of that effort is to get more engineers engaged in public policy, so that we are at public meetings and we are putting out there, the facts about projects and things like that.
Yeah, how's the public policy looking for you guys? And it's public policy in and of itself is always tricky to talk about. But are you feeling good about where it's at right now, or?
Well, funding's always an issue, right?
Yeah, always.
So.
That will never go away,
No.
Of course. How do you think we should get more kids involved in this STEM field? As we mentioned before, you're having trouble hiring people. You need the right people in there. And a lot of kids, I don't think, find STEM necessarily exciting. Any thoughts on how we can improve that?
Well, certainly the earlier that you get people interested in it, the better. I think certainly by middle school, if kids kind of understand what the career path could be, there are a lot of kids that would be really interested in what we do. Certainly when we show high school kids some of the projects that we've done, they really get excited. And those high math and science major types, it's a great career for them, and it's in something they like to do. So,
yeah, I think we need to reframe it a little bit too, because I think that's probably what they're told in school. Hey, if you like math and science, you should be an engineer. And I think we need to kind of expand that to, if you want to help solve the problems of tomorrow, then engineering is a great place to do it, because we're going to be involved in, you name an issue facing society, and there's a role for engineers to help solve that problem. And I think that might get kids a little bit more excited about the positive contribution they can make.
I think so too. I think one of the misconceptions, particularly about the engineering field, is that there's only that you're going to sit behind a desk all day and you're just dealing with numbers, right?
Right.
And that's so not the case for engineering at all. There's tons of avenues that you can take amongst the engineering industry.
Correct. Yeah.
Yeah. Let's talk about one of those things. Artificial intelligence is one of the bigger future things that we're already seeing it, I should say. But it's just going to get bigger in the future, right? And so I think a lot of kids would be excited to learn about artificial intelligence and engineering. Thoughts on that?
Yeah, well, you've seen a lot of that already, and probably in your business more.
Yeah, I think we're starting to see it coming as decision support systems, where a lot of what we do now as calculations, as rigorous design sorts of things, can be done on a computer, and so we've seen some of our clients utilize it, for instance, to evaluate designs and come back with, instead of looking at 5 options, they look at 20 options. They get to pick. So it becomes much easier for the engineer to figure out what to do much quicker.
Yeah, a robust tool. It's, in some ways it'll probably replace what we already do. We have a lot of biologists at our company who will go out and do threatened and endangered species surveys, for example. And there's a company now that has cameras to put on wind turbines that can tell what kind of bird is flying at the turbine from like a half a mile away and shut the turbine down if it's an eagle, so there's some of what we do I can see being replaced, but to Bill's point, it'll free us up to be a lot more creative and to look at a lot of other options on our projects.
Mm-hmm.
That's really exciting.
And be more productive.
Yeah.
I think the level of problems that we have to solve is getting to be so big that
big and complex
that you almost need artificial intelligence to even understand it. So
yes. Any thoughts on perhaps there's an overdependence on automation? For example, autonomous vehicles.
Yeah, I don't know if it's the overdependence, but maybe a sense that they're going to solve all of our problems when, again, it's really complex. And you look at an autonomous vehicle and making the same decisions that our human brains, I don't think we respect our brains enough of like how much information we can take in and sort through in a millisecond and make a decision. So they are finding that fairly complicated to replicate.
Right.
Yeah. Well, and one of the this is a little bit off topic, but I know for myself, you said the millisecond that you have. Typically, I'm trying to decide if I should go faster or slower than the person next to me so I can get around and do some things, and I don't know that an autonomous vehicle would sync up well with my decisions on that.
Well, theoretically, we'll all be going the same speed, right?
Oh, that's fair, yeah.
So, but yeah, that is the question. What if you get a late start?
Right? How is a lead foot like me going to adjust to an autonomous vehicle? What about critical thinking skills and communication skills as far as the future of the engineering profession? Obviously, critical thinking skills are an important part of any career you choose. But as far as engineering, let's talk about those communication and critical thinking skills together, where you see those needing to be applied.
Well, as things get more automated, engineers are, and anybody operating those systems is going to have to really look at them critically to see if they're making the correct decisions. Certainly today, we see a problem with believing what's coming out of the computer, and is it correct or isn't it correct? We have to really look at it closely, make sure that the answer that the computer came up with is correct, and sometimes it isn't, right? So you have to kind of apply some practical rules of thumb to what we see and say, does that make sense?
Right. Yeah, and I think critical thinking's always been a huge part of engineering. I always tell people in engineering school, really what they teach you to do is solve problems and how to approach a problem and solve it in a logical way. So it's more a process kind of approach that includes a lot of critical thinking, because as Bill was saying, you has to pass the smell test at the end of the day. Does this answer make sense? And you were saying in your business, you're going to start looking at 20 different options instead of 3, and maybe the system hasn't seen some of those options before, and so you need to be really looking at it and making sure that it makes sense in an engineering setting.
Yeah, absolutely. And Bill, to your comment about making sure that passing the smell test, if you will, I like that. I guess I thought if I ever saw anything online, if there was an engineer behind it, I just assumed it was true, right? So I should probably do my research as well. Yeah, I like that. I think a lot of us look to engineers as not a say all be all necessarily, but there's some clout behind that title.
Yeah, we all hope so. That's why we work hard. And it is our first and foremost responsibility, right, is the health and safety of the public and the environment. So we all take that very seriously. So, hopefully when you do see something from an engineer, it has some trust behind it.
Yeah, absolutely. So we have a few minutes here. I want to talk a little bit with you guys about your opinions on the future, again, of the engineering profession, as far as where you see this going. Are we going to be including more things that engineers need to do or have as a list of skill sets on a resume?
Yeah, as we were talking about earlier, I think we're going to have to get to be much better communicators. I think we're going to have to be very good at working in interdisciplinary teams. So maybe working together on projects with people who have expertise that we're not used to having on our projects, just because they're more complex and bigger projects.
Yeah. So. As far as, I think a lot of the science and engineering careers tend to put themselves in silos, right? And so this
Correct.
Interdisciplinary, by that, do you mean working with other types of engineers or other industries as a whole?
Well, both. Yeah,
Okay.
You make a good point about we've worked traditionally in silos, and I think that to be efficient and to look at really creative solutions, we'll have to break down those silos. But yeah, working with like groups who are concerned about a social issue, and making sure that, we do that today, but I think it's going to be much more complex and integrated in the future.
Yeah.
Well, and I think we will collaborate perhaps more internationally. There'll be work groups probably all over the world working on a particular problem. So it's going to be a very diverse work group. And automation will probably allow for that, right?
It'll take a lot of leadership to keep things on track as you're dealing across 24 time zones. Yeah.
Right.
Yeah, for sure. Well, we are going to be right back here on Connect and Collaborate. Stay with us. Visit us, cobrt.com/live for our YouTube channel, and visit acec-co.org for more information from ACEC Colorado. We'll be right back. Stay with us here on Connect and Collaborate. Welcome back to Connect and Collaborate. Once again, I am Alex Hopkins, your on-air producer, and we are having our monthly show with American Council of Engineering Companies of Colorado, ACEC Colorado. And once again, in studio, I have with me Lauren Evans, president and founder of Pinyon Environmental, and Bill Green, president of RMH Group. So again, welcome. Thank you for sticking with me. And we're focusing today on the future of the engineering profession. As you both mentioned, you're having a tough time getting people on board. Not a lot of people interested in the STEM fields, and it's just tough, right, to get some people in there and get interested in engineering. But there's so much that you guys do. And talking about the future of that, I have some topics here that I want to get into here with you, Bill. One of those is BIM. I just learned that is bidding information modeling.
Yes.
Yeah.
Building.
I just learned it. It's new to me. Building information modeling. So tell me what that is.
Well, it's basically a full 3D model of a building that includes all the information of the stuff inside the building, such as the mechanical systems, electrical systems, perhaps, could go down into even what is in the building for the tenant spaces and that sort of thing. So it gives owners the ability to manage their buildings better. There's much more information. It's readily accessible to the contractors that are building the building, the maintenance people that maintain the building, and so it's kind of full information about the building.
That is crazy to think about. I guess when I think of 3D model, right, I'm thinking about just the design, and I can see where my chair is and which window I'm going to be facing out of. But you're talking about the basic, the piping that's in through there, where the heat ducts are, everything.
Yes, right.
Yeah.
Well, and Bill, and it makes the construction a lot easier, right? Because you see conflicts where before you actually get out building stuff, you see potential conflicts of equipment.
We can do clash detection before the building's built. You can actually build a building virtually before it's built. You can watch it go up in a time sequence, so you can schedule people, schedule equipment, that sort of thing. You can also use things like Microsoft HoloLens to visualize parts of the building that haven't been built yet. You can stand in a room and see where the walls go up. It can help the construction workers actually build it. And eventually, it will be used to 3D print the building. Wow. So you'll have a robot that starts pouring concrete exactly where the drawing shows it to be poured, and you don't have workers building it. You have robots building it.
That is fantastic, and honestly, mind-boggling, really. So I'm guessing there will never be a scheduled delay again, then?
Except when the robot breaks.
Or the concrete doesn't show up on time.
Yeah, right.
There's always a human element of some sort, right? And technology is not foolproof, though it's certainly improving a lot of what we have going on. That's amazing. Let's talk about cloud computing. Yeah.
Well, Lauren's looking at me like, why don't you talk about that? Yeah. You know what? I think the biggest aspect of cloud computing is the ability to get some, pretty incredible computer resources at hand for almost anybody, so that they can do things that perhaps they couldn't have done before because they didn't have resources to do it. And certainly information sharing with lots of people.
Yeah, just working across project teams in an easy way, right?
Mm-hmm. Yeah. Right.
Awesome. So. You both have had quite a bit of experience in the engineering field, right? Lots of years working in that. The technology has improved, I would say, exponentially, probably mostly within the last 15 years or so. How much easier are your jobs now? Or is it tougher?
Easier,
Perhaps I'm wrong.
I would say easier and harder.
Yeah.
I look back at the start of my career and we didn't even fax stuff to people.
Right.
So we had FedEx. The sense of time was different. You had more time to complete stuff than you do now because everything can be so immediate. So, clients will say, well, yeah, just email it to me, right? It's ready to go. And you're like, sure, can no longer use the U.S. mail as an excuse of why it's not there.
Yeah.
So, but then as you say, there's so many more tools and, things that are allowing us to do maybe a more complete job, right? So we go out to map wetlands and we'll have biologists out on the ground and walking it. Well, now we can use a drone from above and get a much better sense of the complete site than we were able to before, just being on the ground. So,
wow.
in a much more efficient and timely way, right? Which saves the clients a lot of money too. So.
Oh, I would imagine. Yeah. So you might spend a little more on that drone up front, but in the long run, you're really saving yourself and your clients money and time. Time is money, though. Let's talk about virtual reality and its integration in engineering. And again, virtual reality, for someone like me, what do I think of? I think of video games, of course. But there's so much they can do for industry. Yeah.
Yeah, well, you'll be able to see our projects and experience them before they're built, to, going back to Bill and BIM. But on our projects where we're doing maybe more what we call horizontal infrastructure, so building roads or, the light rail lines, people can actually see what it's going to look like from their window, right? See what the impact will be to their world and their space in a much different way than us showing 2D plan sets, on a PowerPoint in a public hall. So it'll, I think, help maybe put it in perspective and people to really understand, how it's going to impact their lives. And you'll be able to show people exactly what their building will be like by walking through it.
Right, exactly.
Yeah.
We're already using laser scanning inside buildings to as-built them if we're going to modify them. And it's not only given us the ability to more accurately draw the existing building, but we can, as the building is being built, we can scan it and see if the contractor is putting stuff in the right place. So we get a complete picture, and we don't have to go out in the field and measure stuff. And it saves huge amounts of time, just huge.
Yeah, I think if they're making a major change to an intersection that you drive through every day, where suddenly maybe instead of turning right to go onto a highway, you go in the left lane to, in a flyover or something. You'll be able to experience that online before the project's done, right? You can actually sit down and say, here's my route. How's it going to look to me? And get used to that change before it even really happens.
That's amazing. I love this. And, one of the reasons that these topics are so important is that they're kind of unbelievable at first, but they're changing the way the world works, and it's going to generate new jobs. Again, going back to that, you're not going to be sitting behind a desk just doing math all day long, right? This is generating absolutely new jobs all the way around, but most specifically within engineering. That being said, I'm going to switch gears a little bit here on you guys and talk about your projects specific to you. How do you expect the nature of your projects will change in the future? I know that's kind of a tough one to chew on.
Well, I mean, I talked about, the use of drones on our projects. That's pretty new already to us. We do things like wildlife surveys where we have wildlife cameras set up, so teaching the camera, is that an elk or is that a deer or is that a mountain lion, so that somebody's not sitting there watching film come in. And so we know what's crossing the road when we're getting ready to design a wildlife crossing or something like that. We know what's in the area. So a lot more high tech to help us do our jobs more efficiently and more completely.
Well, and I think in the future, most of what we do today is going to be fully automated. And so that frees us up to perhaps do more of why are we doing stuff instead of the, rigorous calculations and drawings that we currently do. I think it's going to be much more a collaborative environment of figuring out what's the right thing to do. The computer comes up with choices that we make, and perhaps we push a button and that design is completed, and there's an online application that says how much it's going to cost, how long is it going to take, it's kind of Amazon for facilities, right?
Right, and as you said, that'll help us. We always talk about doing the project right, but it'll help us evaluate whether we're doing the right project.
Yeah. Right.
Evaluate whether you're doing the right project
At all, yeah.
Okay.
Yeah, is this the right project to be doing with the money that we have, or?
Okay.
Yeah.
I gotcha. Yeah. Oh, not even an aspect I had considered, right? But you're totally right about that. What kind of positions do you think will be more prominent in the future of engineering? We talked about, a little bit of these future technologies will be creating more jobs. Description on what you think will come about, maybe other ones that I hadn't thought of.
That's a tough one.
Yeah, but there's all those engineers to make all those things happen behind the scenes.
Well, certainly as things get more complex and more automated, you need people that can deal with that complexity and that automation. Certainly computer science is going to be a big deal. People that like video games are probably going to be doing the equivalent of video games at work all day long. We're going to be in virtual meetings with people probably across the globe. So being able to work with lots of different cultures, lots of different people, that's probably going to be huge.
Data management, big data.
Big data, right.
And cybersecurity. Yeah.
Yes, cybersecurity is a fascinating subject to me. I have been told more than once that the Third World War will be a cyber war. We won't be seeing weapons. It will absolutely be a mass destruction via the web. Yeah. No, everyone watching us on YouTube, beware. I have just a thought for you here. And would either one of you be interested in being a guinea pig for new technology? Anytime new technology comes about, you're essentially a guinea pig when you pick it up. But any thoughts on being the first engineering company to have this type of new technology, right? Would that be something you would do?
That's an interesting question because, a lot of times in our projects, we're held to the standard of the industry in terms of liability. So anytime you're bringing in a totally innovative and new technology, you got to really look at the liability that your firm's taking on, because if something goes wrong and you're defending it, well, you didn't do it to the standard of the industry because you did something new and innovative. And that's something at ACEC Colorado we've been talking about. How do we take these innovative ideas that are maybe being developed in R&D and in labs and at universities and actually bring them into the public sphere in a way that is kind of protective of everybody, right? The companies and the owners and the public.
Right.
So,
yeah. I knew it was a tough question, but I had to ask it because there is a matter of safety, right?
Absolutely.
Yeah, you have to protect yourselves and everybody else, for that matter.
Yeah, and a lot of the work we do is permitted by a local government or a state government agency or even the federal government agency, and those who issue permits aren't always excited to be the first one out of the box on an innovative idea either when they're permitted, because they have a responsibility to protect the public. So. There is a lot of discussion about how do we do this in a better way that we can get these things out and actually using them more quickly than we have been.
Right. Everyone wants to be with that innovative company. Speaking of innovative, what is the most innovative project you have recently worked on? So within the last year, would you say has been the most innovative?
We've done a number of pretty innovative projects. Certainly one that we're still working on here is the CU Boulder Recreation Center. It is 300,000 square feet rec center. We put some systems in there to save energy.
Ooh.
And that rec center is probably one of the most efficient recreation centers in the country. It takes heat from the ice rink that's being pulled out of the ice and it puts it into the pools for heating. It puts it into the building for heating. It kind of uses every last BTU that the building is using. And it probably uses less energy than most office buildings, even though it has this huge sheet of ice for an ice rink plus 3 pools, saunas, jacuzzis, showers, that sort of thing. So very low energy system.
Wow, that is amazing. Sorry, that one sounds awesome to me, but the relation of taking the heat from the ice and putting it in pools, awesome.
Yeah.
I love that.
Yeah, I can't top that. Like I said, a lot of what we're doing is, using tools like drones and things like that. And this will sound like not very innovative to people, but a lot of our projects now are a different, what we call different delivery systems. So, it used to be an owner would say, okay, I want this done, and the engineers would design it, and then the contractors would bid on it. So we're doing a lot more work where that's all happening at the same time. So design build, or even beyond that, a P3, which is a public-private partnership, where suddenly now you have a financing company involved on your project, right? So back to talking about how we're all going to have to get better at collaborating and working with people from industries that we don't usually work with on projects. So.
Well, and you say that doesn't sound interesting, but I want to make
I said it didn't sound innovative.
Innovative. Sorry, innovative. But the fact of the matter is, we have 2 different types of engineering here. We have horizontal and vertical, right? So those are 2 very distinct and different types of engineering, particularly when it comes to infrastructure and things like that. So I want to make sure we are defining that distinction between the 2 of your corporations. Few minutes here left. I wanted to talk to you also about ACEC Colorado. You mentioned the Engineering Change Lab in the last segment. So do you mind explaining a little more of that?
Not at all. That's a national organization that some of us in ACEC in Colorado, so ACEC Colorado is part of a national organization that's just ACEC, and some of us who had met through that national organization started having these conversations about the future of the engineering profession. And we're wondering if we're involved enough in determining what that's going to be. And so rather than being reactive about letting the future happen to us, could we be proactive and have these kind of conversations we're having here today? And then how do we adapt and get ready for that? So we started this organization called Engineering Change Lab US. There's a similar effort going on in Canada. They actually were doing it before us. And we've been having summits. We've had 4 where we invite engineers from around the world, or around the country, to come and have these kind of deep dive conversations and like look at, what are the issues facing us. And I know, Bill, you attended one in October. We've got another summit coming up in 2 weeks in Kansas City that is specifically going to focus on K-12 education and STEM and how do we get more kids interested in the engineering profession. So that's a proactive thing that we're doing to look at that. And ACEC Colorado has had quite a few people involved in that effort. So.
Awesome.
ACEC Colorado tends to be a leader in some of these things.
Right.
I would absolutely agree with you. Working with ACEC Colorado has been exciting. As I said, I learn something new every month when it comes to engineering. And quite obviously, that was not a career path I wanted to get in on, but I wish I would have had those opportunities at least in front of me so that I could have had more knowledge about the profession, and perhaps I'd have a different career if I'd had those options in front of me. Speaking of ACEC Colorado, I want to also push out Legislative Day is a part of Engineers Week, and that is on the 21st. So on Thursday, check out Legislative Day. Below in our comment section on YouTube, we have a link to our blog post that will link you to Engineers Week so that you can check that out and see more specific days they have going on. But you both are involved with ACEC Colorado, as you've mentioned. Do you mind, Bill, talking a little bit about the benefits of being a part of them?
Well, ACEC is really there to help us with the business aspects of engineering. It's not the technical aspects, but legislative issues is a big deal. Things that affect the profession and affect public safety, health, welfare. We're focused on, but really it helps us with, if there is an issue within state government, let's say, or city government that perhaps we need to address. ACEC is the one that helps us do that. And Marilyn Reamer does a great job. She is a true advocate of the engineer. So.
Yeah, it's a pretty amazing organization. Bill and I don't compete on projects, but there's lots of members within ACEC that we do compete with on projects. But we all come together. It's a very friendly competition environment, friendly competitors. And we come together at ACEC to help work on projects that affect all of our businesses. And so we work together on those issues. And then, it is for our businesses. Most of us didn't have business school training when we got out of engineering school. And so, they provide a lot of education and assistance to make us better business owners, because in addition to being engineers, we're business owners too. So,
which is a tough job to navigate, really. Being an owner of a business is not easy by any means. Speaking of business owning, talk about your future projects that you have coming on. What can we see in 2019, 2020 that you're touching?
Well, we're working on the C70 project. We're working on the National Western redevelopment project. That's something I think everybody in the city should be really excited about, what that site's going to become. What have you got going
on? We're doing the Children's Hospital North project. Up on I-25 Highway 7. Doing lots of work out at the Anschutz Medical Campus, certainly.
I am familiar with that. That is my old neighborhood, my old stomping grounds through there. Yeah. I just want them to up the speed limit a little bit, right? I will be careful. I won't hit a student, but it's 25 through there, and goodness, there's a cop everywhere. Sorry, I know that's way off topic. But those are cool. Hospital and Anschutz. What else do you
have? We're actually doing some work at Kent Denver School. We've got a couple of middle school and an upper school going there. Probably going to be close to net zero energy buildings. Could be net zero. So those are exciting.
Those are exciting. And you guys both have a lot of projects that I think the public will touch on quite a bit. It has been a pleasure having you both in studio with me today. I really appreciate your time and coming out here on both President's Day and a very snowy, cold day. So thank you very much for that. Again, you can find more information at cobrt.com/radio-podcast. Type in ACEC Colorado and you can find all of the past shows, including this one. Have a wonderful day. Thank you both so much.
Thank you, Alex.
Thank you.